Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young.
Chapter 9, Geometric Constructions, Invariance. Section 90, Invariance and Covariance of Binary Forms. Definition. If a binary form a sub x to the nth power equals a sub 0 x sub 1 to the nth power plus n a sub 1 x sub 1 to the n minus 1 power x sub 2 plus plus a sub n x sub 2 to the nth power be changed by the transformation pi x sub 1 prime equals alpha x sub 1 plus beta x sub 2, x sub 2 prime equals gamma x sub 1 plus delta x sub 2, alpha delta minus beta gamma not equal to 0, into a new form a sub x prime to the nth power equals a sub 0 x sub 1 prime to the nth power plus a sub 1 x sub 1 prime to the n minus 1 power x sub 2 prime plus plus a sub n x sub 2 prime to the nth power. Any rational function I of a sub 0, a sub 1, a sub n of the coefficients such that we have I of a sub 0, a sub 1, a sub n equal phi of alpha, beta, gamma, delta times I of a sub 0, a sub 1, a sub n is called an invariant of the form a sub x to the nth power. A function c of a sub 0, a sub 1, a sub n, semicolon, x sub 1, comma, x sub 2, of the coefficients and the variables such that we have c of a sub 0, a sub 1, a sub n, semicolon, x sub 1 prime, comma, x sub 2 prime equals psi of alpha, beta, gamma, delta times c of a sub 0, a sub 1, a sub n, semicolon, x sub 1, x sub 2 is called a covariant of the form a sub x to the nth power. The same terms apply to functions I and c of the coefficients and variables of any finite number of binary forms with the property that the same function of the coefficients and variables of the new forms is equal to the original function multiplied by a function of alpha, beta, gamma, delta only. They are then called simultaneous invariants or covariants. In section 87, we gave several examples of invariants of binary forms, linear and quadratic. It is evident from the definition that the condition obtained by equating to 0 any invariant of a form or of a system of forms must determine a property of the set of points represented by the form or forms which is invariant under a projective transformation. Hence, the complete study of the projective geometry of a single line would involve the complete theory of invariance and covariance of binary forms. It is not our purpose in this book to give an account of this theory, but we will mention one theorem which we have already seen verified in special cases. The functions phi of alpha, beta, gamma, delta and psi of alpha, beta, gamma, delta occurring in the definition above are always powers of the determinant alpha, delta minus beta, gamma of the projective transformation in question. Footnote. For proof, chiefly for example, Grace and Young, Algebra of Invariance, pages 21 and 22. Before closing this section, we will give an example of a covariant. Consider two binary quadratic forms, a sub x squared, b sub x squared, and form the new quantic c sub ab equals the quantity a sub 0 b sub 1 minus a sub 1 b sub 0 times x sub 1 squared plus the quantity a sub 0 b sub 2 minus a sub 2 b sub 0 times x sub 1 x sub 2 plus the quantity a sub 1 b sub 2 minus a sub 2 b sub 1 times x sub 2 squared. By means of the equations 1, section 87, the reader may then verify without difficulty that the relation c sub a prime b prime equal to the quantity alpha delta minus beta gamma times c sub ab holds, which proves c sub ab to be a covariant. The 2 points represented by c sub ab equals 0 are the double points, proper or improper, of the involution of which the pairs determined by a sub x squared equals 0, b sub x squared equals 0 are conjugate pairs. This shows why the form should be a covariant. Exercise. Prove the statement contained in the next to the last sentence.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.